The 37-foot Lord Nelson Victory Tug is an ideal cruising boat. However, one of the attributes is the built-in anchor system, which really precludes running any other anchor other than the Danforth style anchor, as shown here. Previous owners of Kedge built this wooden bowsprit that was suitable for storing another anchor, suitable for deploying it, but not adequate to retrieve it. It's held in through the cap rail with screws through these wooden blocks, and it had the feature that it would pivot. So it could be pivoted down if the boat needed to be made shorter. It was also useful for retrieving it. They'd come up with a clever system of rigging a roller into this, into the starboard hawse pipe that would allow you to use the same windlass that's used for the built-in anchor. That would leave this anchor hanging a little bit above the waterline where it'd have to be lassoed with a noose and then brought up onto deck hand over hand. It's a big advantage to be able to run multiple anchors. The Danforth style anchor is very good at what it does. However, in a reversing tidal current situation or with a 180-degree wind shift, the Danforth anchor could pull out and fail to reset. It's also good to have adequate ground tackle, even for unexpected things. Like in this case, in the river system, we were caught by some flash floods and had two complete trees with root balls that were actually longer than the boat. The strain on the anchor was quite remarkable, and getting the anchor ground tackle freed from this was a big mess, but thankfully we were able to do it. Our goal is to fabricate a bowsprit that won't destroy the looks of Kedge, but be strong enough to be able to retrieve the 65-pound Bruce anchor that we've come to hold in such high regard. It would also work for a Rockna or a Delta-style plow or what have you. Now, the first issue is Kedge's bulwark is 2 layers of fiberglass separated by some expanding foam. So we identified where we want the new bowsprit to bolt in, cut in with a hole saw on the inside, and removed the foam. Now, you can see the foam block, and then we basically fabricated a solid fiberglass hockey puck-like thing with the appropriate angle using an appropriate size container that was actually used to hold some laundry detergent as a mold. And then this piece was placed into the cavity once the foam was removed, surrounded with epoxy, and the original disc cut out with a hole saw was put back in and ended up with something that looks like this. These are 2 of the foam blocks removed, showing the difference in port and starboard. I mean, they held pretty good tolerances on the boat, but getting the exact thickness of the bulwark the same is really a challenge on a boat this big. Okay, the next step is to build a wooden model of the hardware we're going to need to mount the bowsprit where we've located these solid points in the bulwark, fore and aft of each of the the bow hawse pipes that we use to moor the boat or tie it to a dock. We want the crosspiece for the bowsprit to be pretty much the same as the original owner's bowsprit, because that crosspiece has been proven to be out of the way when doing work on the foredeck. Once a wooden model is made, we can measure the various angles that are going to be required to be implemented in the stainless steel. The most interesting one is this 77.5 degree crosspiece, and that's going to be hard to achieve with the relatively primitive tools that I've got available. Basically a Harbor Freight circular saw using an ablative cutoff disc. So here are the side pieces mitered at the appropriate angles, and close up on the welds. It's a stick welder, but it's not bad. And now we're locating the center line for the crosspiece by installing these back on the boat. And we've got the cross piece located. Now, I've basically taken some of this square tubing and mitered it at that 77.5 degree angle and then clamped it in addition to cutting the 3/8 bar stock at the 77.5 degree angle. And it's clamped as securely as possible, located, a little bit further down from the top of the mounting plate. And now all that remains to be done is to weld it. And here is one of the finished welds. Here it is on the other side. And holding it up to the model, it looks like a reasonably good fit. And the pieces are checked for fit on the actual boat. So now we want to make sure we know how long the cross piece has to be, and sort of just checking that, and we've got to miter the edges. Okay, the next thing to do is to determine what we're going to actually use for the bowsprit. We need a stainless steel shape that's going to take the load and handle the bending moment. And several shapes were found and evaluated at the local scrapyard, and we ended up evaluating them and settling on this 3-inch by 6-inch stainless steel rectangular tubing. The bow roller had to be fabricated such that it would pivot to avoid incredibly large stresses when you're trying to pull the anchor up over the bow roller. And given that the bulwark is high, it's not like anybody's going to want to climb out on the bowsprit and lift the chain up and over that roller. It's necessary that the chain remain captive in the roller and the anchor remain captive as we pull it up. So cross piece is mitered and installed with the ends sealed up, as well as the main beam. Pivot points have been added at the front, and the whole thing is checked using C-clamps to verify where we want to weld it to the cross piece. And also to verify where we want the mounting plate for the windlass. So again, with the bowsprit installed with the C-clamps, just verifying where we want to do that weld, and we want to remove some parts to allow the chain to fall off the gypsy with ease, and just get the whole thing ready. Now, this is the thing bolted together, sitting on a driveway just to check for fit, and a tab has been welded on the bottom of the bowsprit because in a choppy sea, like motoring into a very choppy sea, we don't want the whole thing to start teeter-tottering up and down. We want it clamped to the stem of kedge. And here it is installed with bolts, looking pretty good, and the side view looks very much like the sketch. So the real test then is to see if it actually works. Overall, it seems to work quite well. I am a little surprised at the fact that I have to tail the chain off the gypsy. I was really hoping that it would fall off quite on its own. I may need to make some modifications of a roller or something as it leaves the gypsy to persuade it to work without having to tail it.